Hello, welcome back. Now in this video we're going to learn about tracing functions, function calls. Okay, specifically the recursive function call. Okay, now as you can see here I've got the codes. The first time calling the function is there, and the definition of the function is here. If, else, two blocks. Okay. On the right is the output of the execution of the program on this linked list with n1 as the root and n6 at the end. The green box is a stack. Stack is the last in, first out data structure, as you've learned. Now, in this case, it's going to be used for keeping the return addresses. When you make a function call, you always need to remember or record the return address, because the function call indicates the program execution will go to a different area. Why do we keep a return address? Because see, program execution is sequential, like this one. 59 is done, and you do number 60. Now, because number 60 is a function call, and that means the program execution is going to be moved into a different area, different memory area. Therefore, you need to remember where to return to. That's what the stack is used for. So in this case, if I call this one, and then I need to remember 61 is the place I need to come back to. So I'll put down there 61. Okay, 61. That's the return address once this function call is finished. Okay, now let's have a look what this call does. You call this function, you pass on n1 as the node. n1 is this one. Okay, the first thing you check is if the n1's pointer, okay, get pointer, is pointing at now. That means if n1 is the end node, that means its pointer would be pointing at now. That's the end of the queue. That's what we want. So if that's the case, you do this block. What it does is trace is basically printing on screen this text, and do the counting. So how many levels you've gone down to, and then trace the level, use the counting. Okay. So and then you print the name of the nodes you are looking at, you're visiting. Okay, that's the end of the list. But if it's not, then you do something different. Okay, so you still need to count because you've gone one level down. You still need to show which one you're looking at, but then instead of returning straight away, you're calling this function itself again. See, exactly same name. Find num of elements. Find num of elements. Okay, exactly same. Okay, and the parameter data type is the same. They're all node type. Okay. So you're calling yourself, but you're not calling yourself with the same entry point, with the same node you passed in. Instead, you're using your pointer, your next level. Okay, so you pass in n1, n1's pointer is pointing at n2, therefore the next one I'm calling is n2. So I'm calling n2. Okay, that as the parameter passed in. Okay, function n2. Now, that's fine. You make the call, but you need it to return at some point when you finish that function. Where do you return to? It's this one. That's the return address. So I need to record here as 75. Yeah, that one is n2. When n2 made its call as the root, and you need to remember 75 is the return address. Okay, so you pass in n2 and then come in again. n2 is the root now. n2's pointer is pointing at n3, so therefore it's not now. This section again is not met. Therefore you come to the else section. Okay, if, else. In the else section, you do the counting, do the displaying, and check the name. That's what you get from here. Yeah, n2, you get that. And then you pass on its pointer. Its pointer is n3, because n2's pointer here is pointing at n3. So now n2 is not the end, because n2's pointer is not now. Let's find out if the pointer itself is the end. Okay, so we'll call this again. When you make this call, when you pass n3 as the node to start with, and you need to remember you return to number 75 again because you're running the same function. Okay, that's always the return address. That's the next line after the one you've done. Okay, so again, n3, as you see, is not the end. N4, so you need to call n4. Okay, when you call n4, and you need to remember where to return to. That's 74.5 when you use n4 as the root. n4, no, its pointer is not now because I'm pointing at n5. I need to call n5 now. So n5 is passed in as the root. Now, n5, okay, when you make the call, remember, don't forget your return address. Otherwise, you're going to know where to return, become homeless. Okay, now n5 passed in is n5's pointer at now. No, it's not, pointing at n6. Therefore, again, you need to do this lot again and call this again. So there, you need to make sure n6 is used as the parameter to call the function. It's a recursive function because it's calling itself. Okay. Now, once n6 is passed in as the root, things has changed. Look at this, n6 got no, its pointer is pointing at now. That condition is satisfied. That's why you do this block of code instead of the one below. In this block, you say I have reached the end, and the level I've reached is so and so, and the element is the name. That is this part. Okay, you can see this output is different from the other 5. The other 5 output is almost identical, except that it's number 1, 2, 3, 4, 5 different nodes you're looking at. Yeah, this one is different. It's because it's from there, that section. Okay, that's good. You finish the call. This block is finished. Once you reach that point, you come to this point. That's the return address, remember? So you return to there, nothing to do, because that's just simply finish the function. Yeah, that's the end. When you finish, what do? You return. Where do you return to? You return there again. Yeah, okay, you finish this whole function. You want to return here. Well, you return. Where do you return to now? Again, is that 75, because you have left that place for 5 times, and then you need to go back to that point for 5 times again. Okay, so for the last time, when you exit this point, this code is completely finished with all the 6 nodes visited. Then you return to your first call. That's the return address 61. That's when this 61 will be popped into the program counter, and you start running this because this is completely finished. That's why you get this line. I have reached the level 6. That's the line it is from. Okay, that's the tracing of the recursive function call. Tracing any function calls is important, not only because it's a tested topic, and it is also the essential tool for any programmers, and it helps you understand the codes much better. Okay, see you next time.